certain question is always in mind before embarking upon the main topics of the paper, that is Metamorphic Petrology and Thermodynamics, which is a branch of geology or applied geology. Why to read Metamorphic Petrology? History of Metamorphic Petrology, significance of Metamorphic Petrology and Thermodynamics. Dear student, I am Dr. Harold Thomas, Professor in Applied Geology, Department of Applied Geology, Dr. Hari Singh Gaur Vishwavidyalaya, Sagar. Today, in this course, I will deliver my lecture on an overview of Metamorphic Petrology. In this lecture, I will proceed under the following heads: Introduction, late 17th century, beginning of 20th century, late 20th century and 21st century. I will cover this topic in two parts so that it will be good for the student to understand the whole topic properly. I believe it will be useful for you before embarking upon the main topic of the paper, that is Metamorphic Petrology and Thermodynamics. Since 20th century, Metamorphic Petrology advances very rapidly. Still, very less compilation work is done. I am trying to attempt the advancement of the subject in terms of field, theory, experimental works and application of new technology for proper understanding of the subjects for the younger generation. The historical development observed by the different milestones, it is first concept based and convey to the student how an idea evolved with time to be a landmark of metamorphic petrology. We know how the metamorphic starts, what are factors responsible for this, how it proceed and why it stop. The answer we can find out through the relation of metamorphism and igneous activities, deformation, magmatism and metamorphism, and role of geodynamics, especially role of mantle and asthenosphere. It is not a static process, but it is usually operates under the influence of changing pressure and temperature and fluid composition, and these are documented in terms of texture, mineralogy, chemical changes and calculated pressure temperature condition, and through all these one can draw the PT path and predict how the metamorphic rocks is evolved. Late 17th century, metamorphic petrology started in the late 17th century when James Hutton of the Edinburgh observed that some deeper rocks show a gradual transition from sedimentary rocks to those whose mineralogical composition and structures have been caused by other than sedimentary. Charles, 1833, recognized the role of heat and fluids in the transformation process, which he called metamorphism. In his book, Principle of Geology, in the year 1893, when George Barrow mapped south of Aberdeen in Scotland, observed the zones or series of the progressive metamorphism in the peltic sediments of the Durlandian series, and observed the 6 different zones on the basis of index minerals. These are chlorite, biotite, garnet, stolite, kyanite and sillimanite. With increase of temperature, the boundaries between two minerals is called isoguard. The isoguard is a line of equal isothermal surface. This type of metamorphism is referred to as Barrovian type metamorphism or progressive metamorphism or regional metamorphism, or even we can say kyanite sillimanite type metamorphism, which was subsequently recognized in several metamorphic terrain of worlds including India. Beginning of 20th century, Austrian geologist Friedrich Becke in 1903 treated metamorphic assemblages due to pressure and temperature. Both increase with depth. He recognized two depth zone of regional metamorphism. Grobenman and Nigli 1924 established three zones, epizone, mesozone and catazone, which are equivalent to low, medium and high grade of Winkler 1979. Goldsmith introduced the phase rule to geology in 1911, known as Mineralogical phase rule. He stated that in equilibrium state, the number of minerals or phases in a metamorphic rocks equals the number of components, because natural rocks are normally subjected to divariant condition, that is F equal to 2, that is F equal to C plus 2 minus P or P equal to C at divariant condition. Ascola applied the phase rule for developing the graphical diagrams of mineral equilibria in ACF and AKF phase diagram. The ACF diagram provide useful to show major phases change, to deduce mineral reaction and to relate mineral assemblages to the bulk composition. Thomson developed the AFM projection in year 1957 for peltic assemblages in the Al2O3, K2O, FeO, MgO projected from Muscovite points. Application of phase rules and the graphical distribution of univariant assemblages in PT space were formulated by Sinemakers in his series of research paper and today known as Sinemaker rules, and very much useful for phase diagram for multi-component system and to understand the metamorphic reaction and stability. Metastability of assemblages in specific rock system, PT and given proportion of components, thermodynamics, base projection, T-X or P-X proposed by the Greenwood 1967 methods. Comparing the mineral assemblages of different bulk composition studied by Goldsmith and Ascola, the differences in mineralogy was conceived by Ascola to represent two different phases, establish a new concept of metamorphic phases. Turner and his co-authors enlarged the number of phases and gave approximate range of pressure temperature for each metamorphic phases on the basis of known thermal stability of minerals. Mayashiro in 1961 realized that regional metamorphism varies from place to place in a plate tectonic setting. Mayashiro originally recognized three different metamorphic phases series. These are phases series were produced by metamorphism under different pressure condition. For example, high pressure, intermediate pressure and low pressure. First, a geolite, prehenite, pumpelite, blue schist, eclogite phases. Second, a typical Barrovian type characterized by kyanite to sillimanite type. And third, an Abukama type of green schist, amphibolite, gaulite characterized by the paragenesis of Andalusite and sillimanite type. The Abukama type is named after the Abukama region in Japan and is similar to the Buchan type of the Dalendian. Each facies series therefore characterize a baric type of metamorphism and on the basis of pressure named as low pressure, medium pressure and high pressure, and also designated by the geographical names, for example, Abukama, Barrovian, Franciscan facies series, characterized respectively by Andalusite sillimanite type, kyanite sillimanite type and jadeite glaucophaene type. Summary. Dear student, today we have discussed in this lecture about the introduction, late 17th century, beginning of 20th century. In my next lecture, we will discuss about late 20th century and beginning of 21st century. Hope it will be useful for all of you before embarking upon the main topic of the paper, that is Metamorphic Petrology and Thermodynamics. For further studies, please read the books and the references given in the text. Thank you very much.